video picks up after the initial grind on a concrete slab that'll be treated with a quartz floor. During grinding, some hollow spots were heard as the diamonds crossed the surface. The chain and then a little further inspection with a hammer reveals there are hollow spots in the surface of this slab. Based on the time of the installation and some other appearance issues, it is believed that there are a couple spots that were created by trapping the bleed water during the placement of the concrete. A little bit of extra work means chipping away the loose material and then vacuuming it, preparing the surface to be filled. The epoxy that's being used is 100% solids fast cure epoxy. The reason for this is because the slab is cold, is somewhere in the 50-degree range. The goal is to fill with the epoxy so that it's right at the ledge of the concrete and then a little bit higher so that it just crowns above the concrete. After this is done, dry quartz or silica is added to bulk up the material, which will raise it a little higher than the concrete, and it'll also make it easier to cut. While this process is taking place, also being treated is a control joint that runs through the center of the floor. The saw that's being used is providing a way to, for the most part, in a dustless way, remove the concrete along the edges to prepare it for a filler of sand and polyaspartic. While polyaspartic is not typically used to fill in joints, this was in a pinch because the joint that's in the floor was not expected to be there. So improvising a little bit, we used a polyaspartic with the hopes that the flexibility of the material would prevent future cracking. The next day, after some temporary heat had been increased overnight, the slab temperature has come up quite a bit. It's at 70 degrees. With the material fully cured, it's time to take a hand grinder and cut down that overfill to bring that material down to a level that is flush with the concrete that surrounds it. Because the material was overfilled, the overfill or excess material has to be ground from the surface until it matches the adjacent area of the concrete, so that ideally once the top coat is placed, any evidence or indication there was a void would not telegraph through that coating. Same goes for the joint. For the purpose of making sure that joint is filled flush and complete, it is overfilled and then ground down equal to the height of the concrete on either side of the joint. Once the patching and the grinding are complete, the 70 grit 10 segment diamond is run over the floor with a rotary grinder to remove any of the preparation marks that were placed in the surface or created by the 30 grit diamonds. The 70 grit leaves the floor scratched, but not so severely that it might telegraph through the final finish. With this smoothing step complete, a dedust is done with the shot blaster to remove the fine dust that was created during the 70 grit process to open up the pores of the concrete and make it as clean as it can be for the primer. The primer being used is a water-based primer. This water-based primer is going to achieve two goals. The first will be to mute out the coloring of the concrete. Aggregate exposure and shading differences may telegraph through the coating that follows this step. Because it is opaque with an added pigment, it is a muted canvas that is a uniform color. The other objective achieved is the surface of the concrete's porosity is now uniform. The primer has sealed all the surface pores so that when the body coat is applied, there is no variation in porosity that might affect the mill build or the mill thickness of the body coat. A few hours later, the floor is returned to apply 100% solids epoxy. This is a 10 mil coat of 100% solids that is tinted gray. The backup color of the epoxy in gray, of course, helps the uniformity and appearance of the gray quartz. Completing this portion of the process, decorative quartz is fully broadcast over the wet epoxy. The process restarts the next day. The video picks up after the loose quartz has been removed by vacuum. Overnight, the temperature of the slab has dropped significantly. It's below 50 degrees. This is because the temporary heat had ran out of fuel in the middle of the night. The temperature drop is not that big of a deal because the coating that's going to be applied next is a polyaspartic. This material is going to be used for the grout and seal portion of the work to cover and protect the quartz floor. This particular chemistry allows its use at a temperature as low as 40 degrees. Since the slab is between 47 and 50 degrees, it's well within the threshold of what this material requires for proper placement as well as curing. The coating of the quartz begins by painting the edges first. It's a simple process of cutting in, carefully applying the polyaspartic to the vertical edge of the quartz on the base, as well as the radius, and then using a small roller to carefully apply the material. Most important is to watch for excess application that can cause drips or runs, or any kind of ridges that would otherwise show through the finished coating, as the material that's been applied to the surface, and then obviously on the flat surface where they come together, there's not going to be any shiny spots. So this amount of material that's being applied should be done carefully, and also preventing, to the best of the installer's ability, any excess material building up along the edge. The flat area of the floor is pretty straightforward. Pouring down the material and then using a flexible squeegee to pull the material across with only medium pressure. The idea is to fully saturate and fill the absorbent quartz, as well as to create some amount of mill thickness along the top surface. Some overlap will help this, and then of course a back roll with a 1/4 inch epoxy glide roller helps to relax that material and let it cure at a hopefully uniform appearance. And that's about it. Epoxy quartz with a polyaspartic top coat.